Well, howdy, physics sleuths and inquisitive souls. Welcome to another episode of Dynamic Gravity. A little bummed. I just recorded a half an hour long episode of this, and audio didn't take. I gotta do it all over again. It is what it is. So, for this episode, now that I have officially finished the math, I actually do have a correction to my math that I put out from my latest video. There was something about how gravity was created by super celestials versus regular objects that I did not incorporate into the theory. Just simply rations it down in a ratio. The smaller the object gets. I'll look for updated video of that soon. But for this video, we're going to go off and finally address the only Achilles heels of dynamic gravity. When I first made this theory like 20 years ago, I sat down. I told everybody, I told dude, didn't give a shit. I was like, hey, I can explain everything. Everything except for one little thing. The pesky bending of light by the sun, or by gravity, gravitational lensing, whatever. I cannot explain that. I don't have an explanation for that. And I thought about it, over the last month or so, now that I've got the math sorted out. I was like, all right, let me sit down and try and hash this one out too and figure out what's going on here. And I did it. I succeeded. I think I know exactly what's going on. And so we're going to dig deep into that. We're going to dig super deep dive. Fun fact, Newton himself never calculated how much light would be deflected by gravity. But he did believe that it would be, because he believed that gravity had weight, because he thought light was like little packets called corpuscles or whatever. When in reality, we know it's more like Einstein's photons, where they're quantized packets of energy, right? So, and that was the reason why, I had this problem with dynamic gravity, because we know light is energy, not really mass. It's not matter. It's energy. You can put it together and it creates a wave function. It plays off of itself. You can put, seemingly infinite amount of photons together and they don't care because they're not mass, they're energy. And energy isn't really affected by gravity, according to Newton. It just doesn't. Einstein says a little bit, because all energy technically can be converted to mass, so technically it is mass in a sense. And that's actually, after my month journey of going deep into this rabbit hole, that's actually very close to what I came out to be. Not quite, but very close. So I have to give Einstein props for, doing Einstein stuff again. But let's dig into this and see if we can't find out what's going on. Okay. So let's do this, all right? We've got a proton, right? But that's not a proton. That's not what it looks like. It looks more like this. It's more 3 up quarks make a proton. And you might be thinking, well, that's not right. It's actually 2 up quarks and 1 down quark. I guess. After you consider the fact that an up quark turns into a down quark after it eats an electron. So this is what a proton actually looks like. Kind of scary ghost face, huh? Now that I look at it. Maybe winking at you. Crazy. So, and then we got our electron right here. All right? Let's make a slightly bigger electron. And you're about to find out why, my child. So, let's move this guy over here. All right. You got an electron, right? And you got a proton. and the proton is just like, I need an electron, I'm freaking out. And the electron's like, oh, I need a proton, I'm freaking out. And so they snap to each other. And it's never been really understood, well, why isn't the electron just go into the proton if it's positive and the electron's negative and they attract? What's stopping them? Well, what's stopping them is this electron right here. That's what's stopping it. As it goes into it closer, it feels more repulsion from this electron, and it keeps it at distance, and it locks it in place. So you got an electron locked into place, right? And the electromagnetic field, which we don't really know exactly what it is, but we know it's somehow a combination of the electric and magnetic field. So you got an electric field and you got a negative charge, right? And you got a positive charge, which you won't even know what that is either. Is it really a charge, or is it an absence of negative charge? Debatable. But we know this, though. This is all scientific facts I've explained to you thus far. This is none of my opinion. This is all known facts. So we get a photon, right? We get a photon just coming along, bloop, 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 hits this electron, gets sucked right to it somehow. Hits the electron, right? This electron gains charge from this photon. Actually, this is more going to my theory. But what we do know is an electron is definitely some sort of oscillating or whatever perpetuating electric field and magnetic field together at perpendicular 90-degree angles according to Maxwell's laws because of curl and all this stuff. And so that's what an electron is. Or my bad, a photon is. It's an electric and magnetic field playing off each other somehow. That's what the theory is. I don't think this is exactly right. I think it's more of an electric charge. It's a negative charge, right? And that makes perfect sense, and you're about to find out why. If it is a charge and it's moving at the speed of light, well, guess what? If it's an electric charge and it's emanating an electric field and it's moving, it's now also creating a magnetic field. So, and then we know electrons have spin built into them. They're not actually spinning, but they are really spinning, but they're not really spinning. Yeah, it's a funny thing, quantum mechanics. So we got this small charge. Think of it as an itty-bitty electron. This is the way I like to think of it. An itty-bitty electron moving, creating an electric field, and it's a charge moving through the field it's creating, so it's going to create a magnetic field. And it's got spin. And so it's spinning through, making a frequency, cycles, whatever. And this makes up a photon. So technically, yes, a photon is energy because it's a charge. But technically, all matter is also an energy. It is a charge, like the electron is a negative charge, and the proton is a positive charge. They're just all charges at the root of it. And charges are not mass, they're energy, by definition. So now all of a sudden, if we think of this, quantum mechanics saying that all mass, it has a energy wave-like function until you measure it, where it condenses to a single point, and then it immediately goes right back to its, wave-like function. This starts to make a whole lot more sense when you understand that electrons are just a negative charge and protons are just 3 positively charged quarks that evade an electron. So we have our negative charged photon cruising around, and it hits this electron. And so this electron eats it, and it gets a little bit bigger. It gets a little bit more electrically negative, right? And we know, this is a fact, that when a photon hits an electron, it eats that energy. And then it goes to a higher orbital state. And you're thinking, higher orbital state? No, not higher orbital state. Higher energy orbital state. So actually, it gets closer to the proton. because it's got more energy now that it has to fight from the proton. So it gains energy from the photon, negative charge energy, which hits the electron, which makes it more negatively charged. Now that it's more negatively charged, it's no longer in its lowest quantum state, its lowest energy state. So it goes to a higher energy state because it's got more energy. It gets closer to the photon, or the proton. But it's unstable for whatever reasons. Who knows? And so it kicks out the exact amount of energy that it just ate to go right back to the charge it normally likes being, the quantized charge. And so it kicks out this photon, the exact same energy it just ate. And then this electron turns into the normal electron, which is now too close to the proton because it is not the same charge as it was a split second ago. So it goes right back to the original orbital state it was in, and it continues doing this infinitely times. It's just constantly absorbing photons, going to different states, moving around, and immediately kicking those photons out. And now, all of a sudden, we start to think of how the field is propagated. We know that the particle, or the thing that propagates an electric or magnetic field and gravitational field, in this case would be according to dynamic gravity, is a virtual photon. It's basically a photon that has no energy, or very little energy that we can't detect it. So any slightest perturbation of movement will create a virtual photon. And that will shoot out and then get eaten by another electron, move it a little bit, and it'll shoot out and just create shooting out virtual photons infinitely as long as there's any heat. That's what heat is movements of atoms, and that creates photons. Heat equals photons. Just know that. So this is how photons are created. They are essentially, by my definition, itty-bitty charges of a full electron. All right? Now, let us delete this. And now let us say that we have a celestial object like the sun, right? And the sun is emitting the positive force and the electromagnetic force. Because as we've described in other videos on how dynamic gravity works, it's essentially the displacement of the electromagnetic force created from the proton that all electrons are attracted to, and electrons are in all matter. As you see now, even protons have electrons. I just learned this recently too. I knew neutrons had electrons in them, but I did not know the protons have electrons in them as well. That's new to me as well. You learn something new every day. So, so you've got a photon, right? And it's cruising by a sun or a star. And this photon, as we discussed, is essentially a very small negative charge, like very similar to an electron, only it's moving the speed of light. And as it moves, it's coming close, and it's negative, and the sun is positive, so it's going to be attracted to it. So even though it's going very fast, it's going to be attracted to it, and it's going to change its direction. It's going to go this direction. It's going to go this direction, and as it hits the sun, it's going to get altered and go a totally different direction, if that makes any sense at all. Okay, let's delete that. So, now we have an understanding of how light can have perceived weight, even though it's not really technically mass, but mass is not really a thing, as we now know from quantum mechanics. Everything is kind of in this energy state of wave-like functions until it's measured, then it condenses and immediately goes back out. Now, when we think of the world as far as negative charges, like from the electron, a quantized negative charge, the smallest it can go is electron size, versus proton, up quark, now everything comes into play, and it works out beautifully perfect for everyone. Light has weight. Quantum mechanics is validated. My theory of gravity can explain everything from the quantum world all the way to the furthest reaches of the universe. And everything works out. Except there's one little problem with this. Newton believed light had weight, as I think we discussed. But he never calculated how much it should be deflected by a gravitational field. So I think the first person to do that was Henry Cavendish. And then he never published his results, though. But Schnorrdal, or some guy like that, like 100 years afterwards or whatever, came along, he did it too. And he published his results. And he came up of the angle of 2 sigma or something, which is basically how much light should be deflected, right? Now, let's see if I can find the actual thing in this. This gets pretty crazy deep. This guy, I think, is making the argument that Schnorrdal got it wrong, and it should be 4 sigma and not 2 sigma. And just to let you know, Einstein, when he first came out with this theory of general relativity, this is a fact, he said that light should be deflected by the sun. Not because light has weight, it doesn't, but because space-time is curved and light will follow the curve of space-time. And he came out with his prediction that light will be deflected by 2 sigma, the exact amount that everybody believed, and the corpuscle theory of Newton gravity believed it should have been. So there was no deviation at all. And then Einstein got some help, like he always did, because he couldn't do anything by himself, even though it was Einstein. We're talking about very serious shit. And he used the Schwarzkopf metric, apparently. I can't find the actual radiation. I've looked. And he came up with 4 sigma then. Instead of 2 sigma, 4 sigma. So basically Einstein said, hey, the amount of light should be deflected exactly double from what Newton's theory predicts. And Newton's theory, if you did the math, worked out to be like 0.87 arc seconds, from the sun. And Einstein said it's going to be double, so it's going to be 1.75 arc seconds from the sun. All right. So this guy is one of many to say, no, actually, Newtonian physics does not say that it should be 2 sigma. If you do it correctly, like Einstein did, it'll be 4 sigma. And I will give Einstein props. He was arguably the world's greatest mathematician we've ever had. I will argue to the end of the time that he was the world's shittiest physicist ever. He really was. He sucked. He didn't know what he was doing. He sucked at interpreting the math. But his math was always spot on. There was never any doubt about his math. The question was, why was his math correct? And he tried to interpret that, and he failed miserably. But his math is still legit, so we have to give him props. But yeah, this guy, he worked out the entire thing. And he says, yeah, listen, it should pretty much be 4 sigma like Einstein. Like you see, this just gets so intense. I mean, this just gets insane. Yeah, here's the arc seconds of Newtonian. Yeah, here's what I'm saying about sigma: G times M divided by C squared times R. All right. And then let's go and look at a different one. That I've looked at so many different derivations of this. Every single one of them are different. You're thinking, well, there should be one correct way to do it, right? Dude, bro, it's crazy. There's like 100 different ways to do it. They all get to the same place. The question is how, which is why I'm very suspicious about it all. You know, there's like every single person I've looked at their derivation has been completely different. And so I'm like, all right, this is crazy, you know. Some people are using cosine, some people are using tangent, some people are using sine, whatever. It just goes on and on and on because there's a lot of trigonometry, trig involved into this. Yeah, 0.84, that's the Newtonian value that they claim. Yeah, it looks like that's in German. Let's see if we can't get some information out of this. This one is not a good one. Let's go. Every single one's different. You're gonna see it just gets to be demoralizing after a certain point. Yep, here's how the angles, how they worked it out on this one. And yeah, they get, here we go. 4. So this is the Einsteinian one right here. 4 times G times M. M is mass. G is the gravitational constant. C is the speed of light squared. R is the radius of the celestial body that's spinning the light. And Einstein comes up with a 4 times this. The Newtonian value, for some reason, they get 2. But they all do it different ways. It's insane. Like, it's really mind-boggling when you get into it. Yeah, see, here's the Newtonian one right here. So, you see, this guy derives it different ways for both. And at the end of the day, all we can clearly say is that Einstein's math and the way that he derived it with a Schwarzkopf metric, it works out. You know, we know that it's, from what we measure, is pretty close. I mean, it's not 100% accurate, but it's pretty close. It's pretty close. It's like 95% accurate, you know? So this is something, I mean, you can see is how long this goes and how much math they're using into this. And blah, 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 blah. They're doing it different ways. They're saying, now we're going to calculate it from this way, the case of tangential velocity around the Earth's geometric axis equal to 0, blah, blah, blah. You know, it's just, there's so many different ways. But at the end of the day, you always seem to get either 2 sigma, this answer, or 4 sigma, right? And we know 4 sigma is the correct way to do it. But you can just see, God, it just keeps going on. This is so insane. It's really mind-boggling. It's beyond my mathematician skills. I am not the world's greatest mathematician. And everybody has different reasons for it, too. That's the really crazy part. This is like Sabine Hasselhoff, whatever. I really enjoy her. She's a great treasure to astrology. But, you know, she says that it is because the extra factor... Yeah, diameter, blah, blah, blah. Here we go. This difference between 2 calculationalities and code between a parameter called y, whatever, corresponds to spinning light predicted because general relativity says y, or space-time curvature, is equal to 1 or something, where Newton claims it's like half. I don't know. The framework... So she's saying it's from the Benedictine of space-time. This guy's saying no, it's actually from the wave-like nature of photons and matter combined, which doubles the effect. It goes from 0.998 to 0.22, and he's saying it's just essentially from the wave-like nature of matter, is what he's saying. So what I'm trying to get to you is that if you ask 100 different physicists and mathematicians to derive this thing from scratch, you're going to come up with 100 different ways to do it. and they're going to have 100 different reasons on why they did this or that or this, or why this is that or that. But at the end of the day, they're always going to come down to one of two answers: 2 sigma or 4 sigma. I go with Einsteinian math. Einstein's math is pretty spot on. Here's a guy. Here's yet another one right here of them just deriving it all. It just goes on and on and on. It's all different. It's all different from what we've seen before. It's totally different. Different ways to do it. Here's a guy who claims that he was able to correct Newton's equations, or Newton's 2 sigma, to the proper 4 sigma of general relativity. When he did it, he claims that the people that did it, like Schnorrdal and Henry Cavendish, they did simplistic errors with their angles and stuff like this. They didn't add both angles. They only added one. That's why there's only good 2 versus 4. It goes on and on. My point is, though, it's very complicated and very confusing. Yes, he started with Newton's theory of law of gravitation, and then Einstein's E equals mc squared, and you combine the two, and then 2 arc seconds, and he ended up getting 4 sigma, like Einstein did. So there are ways to derive this. Don't think that when someone tells you, well, it's 100% guaranteed fact that Newton was wrong and Einstein was right when it comes to amount of opinion light. That's bullshit. We don't know that. It all depends on who you get to derive the math. That's what it comes down to. And you can get this guy to do it this way or this guy to do it that way, and they come up with the answer that's correct. It is what it is, man. It's very complicated. Well beyond me. I'm not the world's greatest mathematician, I admit. Yeah, see, here's Newton's 2KO versus Einstein's 4KO. So at the end of the day, what I'm trying to tell you is that 20 years ago, and for the last 20 years, when I've had this theory of gravity worked out in my mind of how everything should play, I could explain everything, that every observation we've ever made except for one, the bending of light by gravity. And now I finally can. And there's even going deeper into it. We can find mathematicians are more talented than me that are working out, these derivatives, whatever formulas from this or that. They're getting the correct answers that we know light is bent by the sun or by gravity. I try to calculate the dumb way by using G. Well, G pulls this much, and if light has weight because it's a charge, and gravity is all about charges. Excuse me, brain damage. Then it doesn't matter how much weight light has; it'll be bent all by the same amount, just like everything else. This is a fact. And doing that, I calculate that light should only be manipulated or deflected by about 800 or 900 meters as it travels by the sun. Clearly, I'm wrong, because Einstein says no, it's more about 1 million meters, so 10 times more. And from doing all of our experiments, we verified that Einstein is much more right than anybody else at this. So, I don't know. This goes beyond me. I would have thought it's a simple matter of G by, how long it's affected by G, and you're done. And then calculate your angle by how far away you are. Apparently, when you do it that way, you're wrong. So, I don't know. I'm not going to, really get into this squabble too deeply. All I'm going to say is that for the first time, I can explain why light has weight and why it is affected by gravity, and that there are numerous calculations out there using Newtonian, math or Newtonian physics, to come to the same conclusion as Einstein's math. the light should be deflected by exactly 1.75 arc seconds as it travels by the sun, which we measured has been through numerous experiments. Going back to the original one in Principi, off the coast of Africa, you know, from Eddington or whatever, Paddington, I don't know. So, essentially, this is a very good day for dynamic gravity. For the first time, there's no Achilles heel in dynamic gravity. Everything that we've observed ever in the history of man can't be explained gravitational-wise through dynamic gravity. Can Einstein say the same? Nope, he cannot. He can't. So remember that. Let's drink to that. On that note, I guess I will end this video there. As you can see, it all depends on how you want to attack this, depending on what results you're going to get. But the one thing's for sure, everybody believed in Newtonian, gravity, that light had weight, but for the wrong reasons. I've corrected that. I found out that light actually does have weight, to my surprise, but for completely different reasons than anyone else would have thought. So my theory can now explain everything we've ever observed. Hurrah. And on that note, I bid you farewell, and I'll catch you on the next video, probably correcting my math one final time, hopefully. Have a good day. Bye.
Like, subscribe, submit.